Welcome everybody to part 4 of the ESP32 web server Wi-Fi series. Imagine you have a sensor connected to your ESP32, or your ESP32 gathers data through LoRaWAN from many sensors in the field. Wouldn't it be awesome if you could just log into your ESP32 through Wi-Fi and get a graph like this that you see here on the right? It's updated live and it shows you the parameters from that sensor over time. Well, that is what we're going to realize in the session today. Now, as a starting point, we'll use the code where we left off in part number 3. And then we're going to realize this plotting on the ESP32 in 2 steps. The first step will be that we start to use the flash file storage that the ESP32 has. It's like SSD drive that's built in to the ESP32, and we'll store there our files that we need to make the web browser, so the JavaScript files, etc. And then the second step is that we make the actual JavaScript that's required to plot on the screen through the web server. All right, let's get to it. So let's first download the code where we left off in part number 3. So on my GitHub page, you can see ESP Wi-Fi part 3. Select that and download it. Link is of course in the description below. So let's open the .ini file, the ESP32 file. Before we start making changes, let's first run the code, see where we left off. If you compile this, don't forget to update the SSID and the password to that of your Wi-Fi that you're using at home so that your Arduino can log into that. Okay, let's briefly run this. So here the LED controller that we made in part number 3, you can select an LED, change the intensity, and if you open up a second window and navigate to the same address, it'll update the same way, and so you see the same values. Okay, actually, if you coded along on part number 3, I do recommend for you to download the latest code from GitHub. I did make some further improvements and changes to the code. Okay, so let's go back to the Arduino code. And the first thing I'd like to briefly change is that at the moment we need to log into a Wi-Fi and then the Arduino gets assigned, or the ESP32 gets assigned an IP address. I'd like to briefly change this to an access point, as I explained in the video now linked above, so that we don't need to log into another Wi-Fi and we can just, with our computer straight away, log into the Arduino instead. So to do so, I'll make our own SSID, Arduino SSID. I'll just create some sort of a password and copy paste in some IP addresses. Again, this is described in that video that I linked above. And the last change we'll need to do is that instead of trying to log into an external Wi-Fi, we will just need to create our own Wi-Fi. So let me just copy paste that in quickly. If you want to continue to use your router to access the ESP32, feel free to do so. It's just a little nuisance for me here. So that's why I'm briefly changing this. So here, Wi-Fi password begin, that's gone. So here we have an access point that we then set up and set. So let me briefly check if this all works. So connected now to my ESP32 access point, and now by adding the IP address on the top, we can navigate to the ESP32. So the IP address in this case is 192.168.1.1. That's the one I just defined. Of course, you can change this to your liking, and you see nothing really changed. So let's continue. Okay, for the ESP32 to work together with the SPI drive, the built-in one, I noticed that webserver.h is a little cumbersome. You can make it work, but you need to define yourself the codes to read in the HTML files. So that's where I want to briefly change the web server library. And the one I actually want to use is the ESPAsyncWebServer library. Now, This library is very similar to WebServer, but it has some nice features in order to work together with the SPI drive. So the one thing though is that you cannot download the library through the libraries file over here, this manage libraries. You'll not be able to find it there. So instead, we'll need to directly download this library from GitHub and then copy paste it to our libraries folder in our sketchbook. Opening a web page here, this is the ESPAsyncWebServer library. Just go ahead and download that. And then in order for this library to work, we actually also need an async TCP library. So let's go there as well and download this too. The links of these in the description below. Once you've downloaded that, just go ahead and unzip those two libraries. You copy these two folders and then go to your sketchbook location, which is in my case, Documents Arduino. And you will find here a folder called Libraries. And this is where you need to copy these two folders. I already did this. Okay, make sure that is in place, otherwise it won't work. Going back to our Esp32 code, so we now need to change to ESPAsyncWebServer. So instead here of defining a web server like this, so this is going to be as well then async web server, of course. So async web server. And then we're going to make some slight changes on the initialization. So the first thing that we should change is this server.begin. Server.begin should be the latest action. So first we start the WebSockets and then we start the server. Then over here, the server on, we're going to change this a little bit. It needs here a HTTP GET and just an extra variable, and we will define here async web server request. This is just a requirement from this new library. And the send function will change also slightly. This will just be request and then send. Like this. That should do. So let's briefly see if everything works. Nothing changed. I actually got an error compiling because I forgot to delete this line from the loop. See, the previous library needed a handle client in the main loop. The async web server doesn't need this anymore, so we can go ahead and delete this. Let's recompile and see if it works now. So now it's compiled without errors. Please don't forget to always, if you make your ESP32 an access point, of course, every time you reprogram, you need to reconnect to that access point. And there we are, up and running, so we can continue. As a next step, we want to get rid of this string web page. So at the moment, we load the complete web page compressed in just one string and push that out to any client. Instead, we want to start using the SPI drive and have an HTML file on the SPI drive so that we can send that instead. We will do that with the SPIFFS library. This library you will also need to download from GitHub. So let's download that first. That's available over here. The file we need is ESP32FS. And so at the time of recording, this is 1.0. We'll go ahead and select this and it will download straight away. We'll unzip this one. You'll get a folder ESP32FS. So copy this folder. Now you go to your sketchbook location, which in my case is Documents and then Arduino. And inside your sketchbook location, you need to make a folder called Tools. So I already did that over here, Tools without any capitals. So then you copy paste the ESP32FS folder in this newly made folder Tools. So just as a verification, if you now open ESP32FS and then there's another folder called tool, you can open that as well. And then the file structure you should have is your sketchbook location, documents Arduino in my case. Then you see a folder tools, then a folder ESP32FS, and then a folder tool. And inside you have a file called ESP32FS.jar. So bear in mind that the tools folder goes directly in your sketchbook location. It should not go in your libraries folder. All right, if you've done that, you can go ahead and restart your Arduino IDE. And if you restart it, you should, under tools, be able to see a function called ESP32 sketch data upload. That will now be a function with which we can upload files to the SPI section of the ESP32. If you don't see this, but you did copy paste that folder in, do make sure that you have an ESP32 board selected, otherwise you might not see this option. So how do we then in practice upload files? Well, for that we need to go to the folder where our INO file is located. So in that folder we can now make an extra folder called data. We can then move the HTML file to data, like that. Let's open it up. I will go ahead and briefly rename this very long file name, and I'll just make it webpage.html. It's just a little easier to work with. Okay, so back inside our Arduino code, we can upload to the ESP32 by going to Tools and then selecting this ESP32 sketch data upload. I did get an error now. It said that the upload failed. And the reason for this is that I had my serial monitor still open. So I need to close the serial monitor and then the function should work. So the file uploaded. And so the next thing we need to do is to refer to that HTML file in our Arduino code instead of using this web page string. So let's first include the library that we need to be able to get access to this SPI drive. So that is a library called SPIFFS.h, the one that we already downloaded. We need to initialize the SPIFFS. So that's over here when the setup starts and we started our serial interface. We can over here do an SPIFFS.begin. And you can actually check if that was successful. So you could do something like an if the SPIFFS is not successful, you can say serial print ln SPIFFS could not initialize. Obviously, you need to stop your code here because if you're dependent on the SPIFFS drive, but I'll just leave it like this for now. I'll leave that up to you guys. And then let's move over to where the actual web page is initialized because there we need to make some changes as well. So that's over here. We send here our string. And instead of sending a string, we want to send from the SPIFFS. So the 200 is going to go away. We do that SPIFFS. Then we refer to the file that is webpage.html. And over here, we need to identify it's a text HTML. All right. And then the last thing we need to do is make sure that the server has access to the file, and we do that like this. And that should do. So let's run it. So it does compile, but it doesn't work really well. As you can see, there's no LED selected here. And if I change the value, nothing is updated here on the right. And that is because there is an error in the JavaScript. If I look at inspect over here and I go to the console, you'll see here that there's a syntax error, uncaught syntax error in the JavaScript, and it is on line number 74. Now I briefly checked in Notepad++, and we see that here on line number 74, I had inserted these escape backslashes. We needed to do that in the previous code because we compressed it and then copy pasted it over as a string. But now that we have the real HTML file directly, we don't need this anymore. And in fact, it gives you errors. So we should remove these escape backslashes. And so there's 4 of them here at LED intensity and LED select, and then it should work again. Now we made changes to the HTML file, so we'll go ahead and save the HTML file, Ctrl S, and then we need to upload that again to the Arduino. And uploading, as you know, for that HTML file goes with this ESP32 sketch data upload. And again, you need to close the serial interface if you do so. So reloading now the web page, we see that it does work properly now. We can select the LEDs, we can change the value, and that value is changed directly here on the numbers as well. The one thing though that I did notice is that we do still have an error if you look here on the right. And that error, scroll up, is an internal server error. And it took me quite a long time to figure out what it was. So let's briefly do this together. Here, go back to the code, and what I did to figure out what it was is that I added here a little bit of extra code in case there's an error, that it gives you a little bit more information, because right now it just says internal server error, so you don't really know where to search. And so what you can actually do is that we could say here server on not found, then of course the same deal here, ESPAsyncWebServer request. And in that case, if there's nothing found, we need to send a 404 and we just give an error message, file not found, or something like that. All right. That should do. And then of course we need to close this and close it and close it like that. I think it should work. And if I now refresh the browser, then the error changed to here 404, a file not found. And what it didn't find is this favicon.ico. And that in essence is an icon that it would show you on the web page on the left top for your program that you must load in your HTML code. And in our HTML code, we didn't do that. So you can ignore this error. And if you want to, you can of course load an icon on the left top. Hey, maybe we'd even do that at the end of this session here. So all this work and the website still looks exactly the same. So it's about time to do something more fun. Let's go and plot some data. Now there's many different libraries that you can use JavaScript to show plots in a web browser. But you got to take care that for the ESP32, we need something that is relatively small. The maximum memory size we have is only 4 megabytes. So the one that we're going to use today is chart.js. This is an open source library to show plots in your web browser. There's a lot of documentation here online, and it's relatively simple to use. But actually a good example that I found that we're going to base our code on is on W3 School. And that is shown over here. They have some really practical examples of how to show plots and lines. And it's the one here, the line graph, that we're going to use. So from this, let's copy basically the body. So starting under this HTML, we'll copy everything until the end of the script. Then we'll go to our webpage.html. Now there's some functions in here that we won't be needing, like the radio buttons. Let's just remove those. And so we can remove also the script that is related to the radio button. So these 3 add listener events, and then the LED changed function. And here in the processes, this is the process command, is what the JavaScript needs to do when information from the ESP32 is received. And the last else if here with LED select won't be needed anymore. I can delete it like this. That cleans up the JavaScript a little bit. We now have that JavaScript still in memory from the W3 schools example, and we'll place that here on the top. This is just some styling. We don't really need that. So somewhere over here. Now there's one thing though that we need to do, and that is in this example, this chart.js example, there's a reference here to a website. This won't work on an ESP32 because the ESP32 won't have internet connection when it works as an access point. So what we can do is we can just select this link, open the web browser and navigate to this link. You just Control A, Control C. We open in the location of our data folder where the webpage.html is located. And in here we make a new text file. So chart.js, and we copy paste the text that we just got out of the browser into this text file and just press Ctrl S. Just as verification, the chart.js should be about 400 kilobytes in size. Now that we've done that, we can go back to our webpage.html and you can just change this link to chart.js. We just refer to the local file and that works just as well. So let's go and run this on the ESP32. So the only thing you really need to do now is do ESP32 sketch data upload because we only changed the HTML file and we uploaded this JavaScript file. So let's navigate to the IP address. And we see now the plot and the slider we kept still in. So that seems to work all set, but obviously we don't want to show stale static data like we do right now. If you look here in our HTML file, the X values and the Y values are just predefined, so that's not very exciting. Obviously we want to generate data in the ESP32 and then show it here in our web browser. So that we'll do as a next step. In order to be able to send data from the Arduino to the ESP32, we need to now go back to our .ino file. And first I'd like to clean this up and get rid of all those pins that we're writing to here in the ESP32. For our example here, we don't need all this. This just makes coding a little lighter and it's easier for you guys to follow. So also here, pin attach can go, and this can go over here. We got rid of our LED select, so I'll remove that. I'll leave the intensity because we might use that slider. We'll probably just rename it. Then the same holds here for the LED selected. And this LED C right needs to go out. Let me briefly see if it still compiles. Okay, compiles without a problem. Now, the thing is that we want to not just plot a single value, but we want to plot an array of data. Let's say the temperature, how that changed over the last 24 hours. Then you have 24 values that you want to pass from the ESP32 to the web client. So we'll have to make some adjustments to the code for that, because at the moment, as you can see, there's only a send Json function we made ourselves, where you have the type, what you send over, and then the actual value of what you send over. So we'll need to make another version of this that can send over an array. Let's first start with just defining an array. So here we'll just say we have integer array, and we call this sensor values, and this one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, something like that. So 10 values should be fine for now. Then it is also kind of nice to know what the length of this is. So we'll do constant integer array length, and that's 10. Not the most beautiful way to code, but Arduino and length of arrays is always a bit tricky. So let's just do it like this. So now we need to adjust the function below, the send.json, to be able to accept an array. We can just copy paste this thing and make a version that is send.json array. And this will then have, of course, the type, but we'll now send an integer array of the actual values. So array values. Now we define here a static JSON document with a length of 200. That is well sufficient to just send over a single parameter, but we're sending over now an array. So it's best to briefly compute what size we kind of need. And you can do that like this. It's just JSON array size. And then now we need to add the length here. So that would be, and that is the length. Now we need to just send the array packaged in a static JSON document. But we also want to add the type with that. So let's say 100. That would be sufficient. Okay, then of course we need to now replace the 200 here with the capacity, and that should be fine. Then over here we have a JSON object that is still great. We write the type in that JSON object, but with the value, we don't want to just write the value there. We need to create a nested array. So here we'll say JSON array, and that is value equals, and then object dot create nested array, and then value. And we now can write to this value, that pointer that we set up to the object, we can write the individual values. So just a simple for loop. Okay, and then this one needs to be deleted, of course. Okay, and that does the trick. So let's test our send.json array function. And we're going to test that at the point where a new client is initialized. So that is here, this WS type connected. This case is run whenever a new client is connected, and that's where we also send all the variables we have to the client so that they're synchronized. At the moment we only have the slider, so the slider value is sent over here, and so we can just add here a send JSON array, and we do here, what are we going to call it? Graph, for instance, or graph update. And we send our sensor values, and we should be good to go. So that's all we need to do here in the INO file, but let's briefly switch now to the HTML, because we're now sending data to the JavaScript, but we need to be able to receive this event graph update there as well. So here the HTML file, and we'll scroll down where we see our script, and in the script we see process command. So that's whenever we get an event from or something sent from the ESP32 to JavaScript, then we can process it here. We already see here an if compare to LED intensity. So whenever the LED slider changed, it runs that. And now we can do an else if, and we compare to, we called it graph update, I think. And so the only thing really we need to do here is plot it now to the console to just have a look at what it is that we're receiving, what this array really looks like. So we receive, of course, object.value. So that's what we're now going to have a look at. And you see I did mess up here the layout a little bit. This should be indented further, and we need one more bracket. Okay, so with that, let's compile this and go back to our INO file briefly. We will need to run this sketch data update, and we'll need to compile and upload the software. Now sometimes, and this is typically when you do a lot of uploads, and so you'll probably run into this yourself, sometimes it doesn't find the ESP32 at this IP address. So the problem is that if you program that SPI drive a real lot, then sometimes it cannot get to that IP address some way or the other. What you need to do is just power it off, power it on, reprogram, and the problem is then fixed. Or what we're going to do now is you just open the serial port, we just briefly reset, and if you reset, it will tell you it's now at IP address 192.168.4.1. It's always 4.1, don't know really why, but you can just go there and the page will load. So this is the page itself. We've already seen that, but what we want to now know is whether or not we've received the array that we sent over from the Arduino. So right mouse click, go to inspect, and here go to console. And in console, we actually see that we received an array with the size of 10. And if we click here, the arrow, then we can see the complete array. So 1, 2, 3, 5, 6, 7, 8, 9, and then 0, exactly what we've sent. Okay, so now the next step will be that instead of just plotting random static numbers, we take these numbers over here and plot them on the graph, like over here. For that, we need to go to our JavaScript. In order to be able to write the Y values of chart.js, it's a little tricky. So there's a couple things we need to do. So let's first just delete all these Y values, the preset Y values. And for the X values, sometimes you might want to have an array of length of 10, sometimes an array of length of 20. And so what we're going to do is just introduce a X values array. Then we'll have maybe an array length. And 10 is where we would start out with. And we just want the X values to be 1 to 10, for instance. So we'll just do a quick for loop for that. So that should do for the X values. And then let's have a look at the chart. We'll leave the chart as is, although we want to remove here or change at least the ticks. We'll go from minimum of 0 to a maximum of 10, because that's basically what we're feeding to the plot. And then we need to be able to refer to the chart. At the moment, we just define the chart like this. We need to change this a little bit and add a constant my chart, and that equals a new chart. That way we can refer to this later on. Otherwise, we can never change those values of this plot. All right, that should do. And now we go back to our function here where we process commands that we receive from the ESP32. And there we instead, okay, we just looked at the variables. Great. Yeah, we saw that they were there. And now we can write them to the data set. So it's my chart. And this depends on the type of chart you have. But for this type of charts, it's mychart.data.datasets. And we then have the first one. So we only have one trace. But if you would have like 4 traces, then you can identify which trace you're going to update. And then the data needs to be basically the objects.value, whatever we received, right? And then we need to provide a command that the chart is updated. And that is just an update command like this. That should do. Now we only updated the web page, so we can just upload that data and refresh the page. So let's briefly refresh. And sure enough, we see 1 to 9 and 0. So now we plotted the array we defined in the ESP32. Let's briefly go to the ESP32 code. This array is very static, but instead of a static array, let's update it periodically. We redefine the definition of the array like this, and then we introduce the same periodic updates that we had, for instance, in part number 2, right? Where we periodically send information to the ESP32. So you can go ahead and copy paste that over, where we would have an interval and we would take notion of the time, and then every second that passes by, we send out information to the web interface. So in the loop here, we do the same. So let me just copy paste that over as well from the from part number 2, the code we already wrote. So we have an unsigned long, which is the time that it is right now. And we just compare the time that it is right now with the last time that the function was called. And if enough time has passed, we can go in here and reset the time so that we can count out another second. So what I want to do is create a sort of first in, last out, a FILO queue, where we will change the new value that basically comes in. So we're going to create a small for loop where we're shifting over the newest value to the one but newest, etc., etc. So we go from 0 all the way to array size, but then -1, because we're just moving it over, so it's always 1 less. And here we take their sense values. And we just move them over, right? Sense value 0 becomes 1, sense value 1 becomes 2, etc., etc. And then we have our last sense values that we need to now update. And there we can use a random function. So this is then the array size -1. So we can, for instance, take the current value and add a random number. Our plotting range is only from 0 to 10, so let's maybe keep it within that range. Of course, this is just some random number we generate, but obviously you would just read out your sensor value and send this over to the JavaScript. So then we can do send JSON array, and we called it update, or no, graph update, and sense values, and that should do. And it's not array size, it's array length. Keep on making that mistake. And look at that, it's updating automatically. Here we have our graph, periodically updates, and everything is working. Okay, so there's one more thing that we really should do, and that's clean up our HTML a little bit, because what a mess. I mean, everything is just written all below each other, and you don't really want that. So let's briefly open up the data folder, and in the data folder we're going to make a javascript.js file, and all the JavaScript we have will go in there. So let's go through this. We have some script over here. Let's take that out. Of course, without script itself, you don't need that in the JavaScript file. It's obvious that it's JavaScript. And then we have some script over here that we need. And I'll definitely need to fix those indents, but okay, that's a minor thing. Good, now we have all the JavaScript here together, and we can simply here refer to the JavaScript file and be done with it. Now, while we're at it, let's add that icon as well, that we get rid of that stupid error that we just saw. So let's just briefly open up a page and go favicon download. Probably are some free icons over here. Let's just take a random one. Who cares? We'll take the globe. Beautiful. Yes, whatever, download. So here's our icon, and we're going to take this and put in our folder. Let's call this favicon.png. Okay, now we go back to our code, and in the HTML, let's briefly see, it can be added, for instance, over here, somewhere in the head, doesn't really matter. There we can link icon, and type is of course an image, and it's even a PNG. Href is favicon.png, and that should do. So make sure always you save over here before we upload to the Arduino, obviously, otherwise it doesn't work. Okay, so let's update again. And we see the error is gone. We have our beautiful globe here on the top, and everything's working. So now I have a little bit of a challenge for you. So this is pretty much the end of the video, but why don't you try now to use the slider that we kept in here, so that with that slider you can change the amount of randomness that we add into this number. So let's go briefly to our code, and in the code we have here the slider range. It goes from 1 to 100. Let's just do from 1 to 10. And the starting value is of course then 5. Whenever you change the slider, if we briefly go now to the Arduino code, that over here we want this 5, this random number, to be whatever the slider is. So please go ahead and try this out for yourself. I'm quite sure that if you followed part number 2 and 3 of the series, you should be able to do that. We have all the information. Here in the console, you see whatever number the slider gives out. So try that and let me know in the comments below if you succeeded. So good luck with that and see you in the next video.